All right, let's say you're stuck in the middle of a train with no internet and you have to answer this question in order to survive. You have no graphing calculator, no Desmos. What are you going to do? So here's the question. A tennis ball is tossed vertically upward according to the height equation h equals negative 16t squared plus 21t plus 5. At what time will the ball be at its maximum height? Okay, well, where is that located? The maximum height is located right here, and that is the vertex. How do we find the vertex of a standard form quadratic? Well, that's going to be that opposite of b divided by 2a. Okay, well, what's the opposite of my b? That's going to be a negative 21 divided by 2 times your a. Well, your a is a negative 16. So what is this going to give us? Well, this is going to give us a negative 21 divided by a negative 32. And since you're pretty much a genius, you can do this in your head. 21 divided by 32 is 0.656 seconds. So you just found your x value of your vertex to be 0.656. And so that is, of course, your time, because your x value is your time. Now, if I asked you where is its max height, or how high is your max height, you would take this 0.656 seconds, you would plug in for t, and you would get that second coordinate, which of course would give you the height at that particular time. But this question did not ask you for that. All right, this one does though. It says, how high will the ball be at its max height? So we're going to go ahead, and it's the same exact equation, is it not? Yes, it is. We're going to take this 0.656 and we're going to plug it in. So we're going to have negative 16.656 squared plus 21 times 0.656 plus 5. And I was kind of joking. You certainly can pick up your calculator and do this division right here, and you can do this math in your calculator. But the point is that you don't necessarily have to use Desmos, and you don't necessarily have to use the graphing feature of your calculator. So what am I going to get here? And maybe you want to check that you get the same thing. I get 11.89, and that's going to be feet. So if you want to go back to that last problem there, you can see that we would have had an 11.89. That y value, remember the y value is your height, your y. Hi, Jasper. No, get off the counter. All right, last question here. Find the time when the chicken reaches its max height and give the max height. So we're going to start with this negative b, or opposite b over 2 times a. So that's going to be the opposite of b is a negative 48 divided by 2 times negative 16. So that gives us a negative 48 over negative 32. And that negative over negative is going to give us a positive, and this is going to be 1.5 seconds. So this is the time when the chicken reaches its max height. That's our first answer. Then to find our second answer, we're just going to plug that straight in to our t. Every time I see that t, I'm putting parentheses around my 1.5. I'm going to now plug that into my calculator, and I get a height of 39 feet. And I do remember that this answer was correct when we used Desmos to find it as well. So what am I trying to say in this? I'm just trying to say that you can use that opposite b over 2a, or negative b over 2a, to find that x value, which is your time of your vertex, or the time when it's reaching that max height. And then just plug in your x value of your vertex, or your t value, and you're going to get your maximum height of that y value, or in this case, h. Thanks for watching, everyone. Be joyous.